Hey everyone. So I wanted to make some more videos from the feedback from that feedback quiz I asked on Schoology for you guys to take. A lot of you said you wanted more videos of me teaching, so I'm hoping that this will help, and I'm hoping that we can continue doing this into the future. But let's get started for today. Today we are going to be studying a new chapter, a new section of the book, and so this is going to be a 9.1. Let me just move this up so you can actually see what I'm doing. So we're going to be doing 9.1, which is adding and subtracting polynomials. Okay, adding and subtracting polynomials. There we go. Polynomials. And so before we get started, I want to kind of review about what polynomials are. Polynomials is pretty much just an equation or an expression with variables, and a certain number of terms. So I know that's probably not the best definition of what a polynomial is, but let's just think about it. Let's say, okay, well, what we have is these kind of classes of polynomials, and we have a monomial. And a monomial is a polynomial with one term. And so an example of a polynomial would be just something with one term by itself. So an example I have here would be like 5x. An example I have here is 7 or 3yz. Those are all just one term. They're by themselves. 5x is one term. 7 is another term. 3yz is another term. Whereas when we start adding more and more terms to it, that's when we get a different name and things become a little bit more, I think, a little bit clearer as to what a polynomial is. So here, if we don't have a polynomial, we have a binomial. That is two terms. Okay, so an example of that would be like 3x minus 1, 2z plus 5y. So for instance, in each of these, now I have two terms here, 3x and minus 1. That is one, those are each one term in that binomial. 2z and 5y, because those are two terms, that's going to tell me I have a binomial. 2z is a term, 5y is a term. Thirdly, and if you kind of think about this, it kind of makes sense, because mono means one in math, bi means two in math, and three in math, and is kind of based off of the triangle. This is called a trinomial. Tri means three. This is going to be three terms. Okay, so an example of that would be 2y plus 3z minus 1, or 6x squared plus 2x plus 4. Each one of those has three terms. One term in the first example is 2y, the next term is 3z, and the last term is minus 1. Next we have 6x squared, another one we have 2x, and another one we have 4. So each of these are different terms in this trinomial. So at this point we might stop and ask you and say, okay, an example, classify each polynomial. Classify each. And so I'm going to give you kind of two examples. Okay, so I've got 2x plus 7. I've got 4x squared. Well, 2x plus 7, I know that is two terms, 2x and 7. Those are two terms combined by an addition symbol. That is going to give me a binomial. Two terms means binomial. Okay? So actually, I'll just kind of put everything in, so if you're still taking notes on the top part, you can still see it. But two terms means binomial. 2x is a term, and 7 is a term. Okay. And of course, if at any point of this video, if you need more time to stop and pause, feel free to take a pause, collect your notes, and finish it up later. Okay? Here, this only has one term. There's no addition, there's no subtraction here. So this tells me I only have one term. Well, one term, if we look back up here, one term is a monomial. So this is a monomial. Oops. So that is how we are going to classify different polynomials. Determine how many terms there are. A good way to look at this is how many additions and subtraction signs are there. Okay, this had 0, so it was a monomial. This one was by itself. This had 1 addition sign, so that means there was 2 terms here, making it a binomial. Okay. If there was a trinomial, that would have 2 addition or subtraction or a combination of both in that polynomial. Okay, so we have monomial, binomial, and trinomial, and really anything of 4 or more terms, and this is why I didn't really talk about it, anything of more than 4 or more terms, we really don't have a classification for it. What we just say is, well, this is just a polynomial. A polynomial with 5 terms, a polynomial with 7 terms, okay? But for the most part, what we're going to be dealing with is these monomials, binomials, and trinomials in this chapter. You might get some questions with polynomials, but not too many. Like I said, most of those will be in those 3 categories. Okay? So, really what we have to talk about today is, well, now that we have a classification here of a binomial, a trinomial, and a monomial, now what we can do is we can say, okay, well, let's take these monomials, binomials, and trinomials, and let's add them together. So it's an add them and subtract them. So how we are going to add or subtract polynomials is step 1. Really just, first off, I'm actually going to, you know what, I'm going to only do addition first, and then I'm going to move to subtraction next. So I'm going to say adding here first. This is going to be adding first. So when you're going to add 2 polynomials together, when you're going to add them together, what we're going to do first is you can just write them horizontally, right? Horizontally. And then step 2, once you've written them horizontally, this is kind of only 2 steps. Here, once you've written them horizontally, simplify by combining like terms. By combining like terms. Okay, that's the key thing here. You have to make sure they're like terms. Like terms. And so, again, you might be asking yourself, so let's take a little bit of a breather. Now that I've been talking about like terms, what are like terms? Well, like terms are terms with same variable type. So an example, 3x and 7x. Those are like terms. 4 and 7. Actually, let's make it -7 just for fun. 4 and -7. Those are like terms. 3y and let's just say 12y. Those are like terms. If we want to make it a little bit more fancier, I can say, okay, let me just move this up. I can say 5x squared and 2x squared are like terms. However, this is where things get a little bit tricky. X squareds are like terms to each other, but x squareds are not like terms with x's. X's and x squareds are not like terms. Okay? Those don't have the same variable type. X squared only goes with other x squareds. X's only go with other x's. Okay? So, now that we have that down, let's just say, oftentimes in math class, you'll get this notation here. So let's just say I have two functions. Oops, that's not what I meant to write. Kind of messed up already. F of x and g of x. Really what this just means is you have 2 functions. You're going to see this a lot in the future, so I feel like it's a really good way to first start talking about it. And we did talk about it a little bit earlier. That was function notation. So with function notation, if I have, okay, let's say I have 7x plus 2. G of x is x squared minus 4x minus 1. Okay? Those are my 2 polynomials. And if you want to get more classification with that, f of x is a binomial here because we have 7x and we have 2. Those are 2 terms, 7x and 2. And g of x is a trinomial. We have x squared minus 4x and minus 1. Those are our three terms. So because f of x has two terms, that is a binomial. Because g of x has three terms, that's a trinomial. And so step one, what I'm just going to do is I'm going to write these horizontally. It's going to say, okay, your question might become, right, f of x plus g of x. Add those two functions together. That's really what that means there. F of x, take f of x and add g of x to it. So add those two functions together. So what we're going to do is I'm going to take f of x, 7x plus 2, and I'm going to take f of x and I'm going to add g of x to it and combine it into a whole. And so what we're going to do is take g of x and get x squared minus 4x minus 1. And a lot of times you might see people even put that around parentheses to kind of distinguish what is f of x and where g of x starts. This is not really important with adding two polynomials together, but it is very, very, very essential when you're subtracting two polynomials together. So if you would like to start getting in the habit of separating your two functions, f of x is not in parentheses, but because g of x is second, I am going to write that in parentheses. So here, because g of x is second from here, I'm going to write that into parentheses. That's a really, really, really good habit to get into. And then at this point, what we ask ourselves is to simplify by combining like terms. Well, let's ask ourselves, what are like terms with 7x? Well, the like term with 7x is negative 4x. So 7x, so actually I'm going to kind of combine them over here, plus negative 4x is one pair of like terms. I'm also going to add like terms with 2. Well, 2's like terms is negative 1 here. 2 and negative 1 are like terms. And last but not least, so I've taken care of 7x, 2, negative 4x, negative 1. I still have this x squared I still need to have on here, so I'm going to add x squared. That one does not have any like terms with it. And that's mainly going back to f of x. F of x does not have an x squared here. So I can't combine that with x squared here from g of x. Way over here. Okay. So at this point, just simplify by combining these terms. 7x plus negative 4x, that is 3x. 2 plus negative 1, that's 1. X squared is x squared. And oftentimes we like to kind of put this into descending order of degree. And I didn't talk about the degree in this video. So what I want you to do to actually get an understanding of what degree is, I want you to look at the posted notes that I also do have on Schoology on there for you. And I want you to look at that. What does the degree mean and how can we find it? Okay. But what I'm going to be talking about right now, and if we want an extra video for that, please give me an email. Send me an email saying, hey, I want an extra video on degree because I feel like I need it. But right now I'm just going to leave that to that written work. And I'm just going to say, okay, hey, given that we know what we know about degrees, what I want this is to be in descending degree, which means I want the highest degree. And kind of going over it again, what's the degree of 3x? Well, that's just what the exponent on 3x is. Well, the exponent on x is 1. The exponent on 1 is x to the 0 power. So this has a degree of 0. And the degree on x squared, that is 2. We can see it. So really what the degree is, just kind of going over a little quickly, degree is just the exponent on x. When you don't have an x value, so in this example we have 1, when we don't have that x on 1, that degree is 0. So when you don't have an x on it, that degree is 0. But if you have 3x to the first power, that degree is 1 because there's a 1 on the x, and x squared has a degree of 2 because that is the exponent on x there. X squared is x to the second power, and so the degree on x squared is 2. And so at this point, what we would do is I would write this in descending degree, which means I'm going to start with my largest degree and I'm going to write it all the way down. So from my next largest to my smallest. So here, my largest degree is 2 on x squared. So I'm going to write x squared first. My next is 1, which is plus 3x. My next one is 1, which is my degree of 0. So I'm going to write this. So in other words, if you want to think about it this way as degree, you start with x squared, then you go with x, then you go with 1. If you started with x to the 4th, then you go to x to the 3rd, then you go to x squared, then you go to x, then you go to the constant, whatever it is. If it's 1, if it's 5, it's a 7, if it's negative 13, things like that. Okay, but really here, this is our final answer. We added those two together and we combined it. And again, if you want more help with degree, please let me know and we can talk about that in another video. Also, I do have that in the written notes. So if you haven't checked that out yet, before you email me, look at that notes before we can make a video for that. But here, we have one more thing to talk about, and that is subtracting. Subtracting polynomials. Okay, first step in how to subtract polynomials is to write horizontally again. But my big note is here, don't forget parentheses. I'm going to write this big because it's such an important topic. Don't forget to write your parentheses. Do not forget to do that. That is such a huge part of this section, is make sure when you write these horizontalies that you also write the parentheses to distinguish when does one function end and when was the next one begin. Because when you're subtracting an entire polynomial, you are going to have to move to step 2, and you're going to have to distribute the negative sign. Distribute the negative. Once you do that, now we can just treat this like any old addition, because it's like changing, it's like, for instance, doing 3 minus 4. And now, whoops, I didn't mean to put the parentheses there. But now it's like saying, once I distribute that negative, now it's like saying 3 plus negative 4. It's like changing it there. I'm putting parentheses randomly places, I'm sorry, but it's like going, like, I'll rewrite it. 3 minus 4, it's like changing it to 3 minus plus negative 4. It's like taking that minus subtraction sign and I'm bringing it or distributing it to that negative 4. It's like doing that and now changing the subtraction to an addition. Once we've distributed the negative, then we're going to simplify by combining like terms. So that is just like the last step of adding, combining like terms. Okay? So these are our 3 steps when subtracting polynomials. I'm going to give you a little bit of time. If you need to pause it, or finish up writing your notes. Oops, sorry. There we go. Subtracting is right there. Okay. So what I'm going to do now is I am going to take our previous example, this exact same example, but instead of adding the 2 functions together, adding these 2 polynomials together, I am now going to subtract the 2 polynomials together. I'm going to subtract. So if I have right here 7x plus 2 and x squared minus 4x minus 1, and now I want to subtract those. I want to take f of x and I'm going to subtract g of x. Okay. Step 1 was we were going to write this horizontally. Write it again horizontally. But here, order does matter. Because I'm taking f of x first, I have to write f of x first. 7x plus 2. And now I'm subtracting, and this is where things get needed. You need your parentheses. Do not forget your parentheses. You are going to need it for every question you have with subtraction. Do not forget your parentheses. Okay? Have it. So this is g of x. What's inside the parentheses is, sorry, this is f of x. What's inside the parentheses is g of x. And I'm subtracting the 2. At this point, we are going to distribute our negative or our subtraction sign. And by doing that, that now changes the subtraction to a plus. So now I'm going to take this subtraction sign up here and I'm going to distribute it across. Okay, that takes it to a plus. But a negative times x squared is negative x squared. A negative times negative 4, that's positive 4x. And a negative times negative 1, that is positive 1. So we're distributing, taking everything pretty much in the reverse sign that it is right now, and we're distributing the negative to it to do so. So negative 4x changes to positive 4x, negative 1 changes to positive 1. And at this point, what we need to do is step 3 here is combine like terms and say, okay, 7x and plus 4x, that is 11x. 2 plus 1, that's 3. So again, we've taken consideration of all the x's and all the numbers. Negative x squared is by itself. And again, we like to rewrite that in descending order. Okay. Minus x squared plus 11x plus 3 is my correct answer. Okay. So I do want to talk about this again because, again, it's so important. So important. You cannot, and actually, I'm actually going to write it below here. You cannot forget to put parentheses. And the reason why this is, sorry, I kind of squished it to the end, but the reason why we cannot forget our parentheses is because a lot of people like to write it without the parentheses. This is what's wrong with this. Because a lot of people don't. A lot of times I see this. I see people. Hey, I don't want to put those parentheses there. Well, let's see what happens if I take f of x, subtract g of x without the parentheses. Now it looks like I'm not doing any distributing of this negative, where that's a key part of above. And a lot of people like to say, okay, what's 7x minus 4x, and instead of saying what's 7x plus 4x, which is the correct way to do it. And the reason why we get this plus 4x was because we distributed the negative from up here and we changed it to minus 4x. But again, down here, a lot of people see this and say, okay, well, what's 7x minus 4x? Well, that's 3x. 2 minus 1 is 1 plus 1, and then minus x squared. And a lot of people get x minus x squared plus 3x plus 1. That is not the correct work. This is not correct. Not correct. You need to make sure you put that parentheses because it's important for us to distribute that negative. And again, what else would I said was putting the order here did matter. So I could also do, if I wanted to, g of x minus f of x, and it would be the exact same process, but the answer would be different. So if I take g of x now, x squared minus 4x minus 1, take the parentheses, 7x plus 2. So here I have g of x, and I'm subtracting all of f of x here. So I put that parenthesis there. Now my next step is to distribute the negative. I get x squared minus 4x minus 1 minus 7x minus 2. And now what you get is well, x squared doesn't have any like terms, so we just get x squared. Minus 4x minus 7x, that's minus 11x. Minus 1 minus 2, you get minus 3. Okay? So order does matter. This was my final answer here. Instead of negative x squared plus 11x plus 3, we get positive x squared minus 11x minus 3. So order does matter in which way you're subtracting it. It does matter. So make sure you're putting it in the right order. So I think really the toughest part is making sure you put those in the right order, and as well as making sure you put the parentheses here, because allowing the parentheses tells you you're going to have to distribute the negative. Okay? So again, if you have any questions on any of these notes that we've done so far, subtracting, adding, degrees, how to classify polynomials, that is a good time to ask me in my emails, because again, I'm not getting many emails. So I would like to get some more emails from you guys to get some feedback, because then it tells me, do we need to spend more time with this, or are we good? So I would really appreciate it if we got more emails, as well as starting to do some of the homework assignments, because that is the only way for me to be able to tell you, are you doing the homework or not? So my only goal for you today is to watch this notes. I also want to check your understanding by doing the quizzes. Once you've done the quizzes, look at the note sheet and you'll be done. I'm going to have that quizzes to be the homework for today, because I know this is a longer video. This is already 24 minutes, so I want to make sure that you have time to do other classes. So I want you to do this, look at the written notes, and do the quizzes. The quizzes will be your homework for today. Okay? So make sure you do that. Email me with any questions, and I will talk to you guys again through my daily videos and through other videos like this on Thursday. So please let me know if you have any questions, and I'll get back to you as soon as I can. Thanks.